Okay, so I wanted to record these problems and make them available on YouTube so that you can review and study for the test. The very first question says, find your average speed if you run 50 meters in 10 seconds. So the best way to handle that is to set up your givens and do the stuff that I've been trying to get you to do in class. Now my board's acting all goofy. Let's see what we can do. Get rid of all that. Okay. So I'm looking for the average speed. My distance is 50 meters. And I'm going to put a decimal there. That'd give me 2 significant digits. My time is 10 seconds. There's 2 significant digits there. And I want my average speed. And I know that my average speed is simply distance divided by time. My distance is 50 meters. My time is 10 seconds. So my average speed is 5 meters per second. 2 significant digits. Put your units on everything, every number you write down. No naked numbers is what we call it at my house. Every number needs a unit. Okay. Number 2 says a cyclist travels for 30 minutes, so time is 30 minutes. And again, I'm going to put a decimal there so that I have 2 significant digits. My average speed is 10 kilometers an hour, decimal. And they want to know how far does a cyclist travel. Well, I know that D is equal to average speed times time. Average speed was 10 kilometers per hour. But notice that I have an issue here because I don't have an hour, but I know 30 minutes is equal to half an hour. So if I do D is equal to average speed times time, half of 10 is 5. So in my half an hour, I have gone 5 kilometers. I need 2 significant digits. And I need to put a box around my answer. All right, the third one. Third one says, what is the acceleration of a ball that starts from rest? So VI is 0. And accelerates, rolls down a ramp, gaining a speed of 25 meters per second. So VF is 25 meters per second, and that's 2 significant digits. And the time that it takes is 5.0 seconds. And they want to know the acceleration. Well, acceleration is VF minus VI over T, 25 minus 0 over 5. My acceleration is 5 meters per second squared. Number 4. On a distant planet, a freely falling object has an acceleration of 20 meters per second squared. What speed will the object drop from rest? So VI is 0. Acquire after falling 1.5 seconds. And I want to know the acceleration and the distance covered. Now the distance covered, I'm going to call this time 1 because the distance covered is the time is going to occur for 1.8 seconds. So I'm going to make this be 20 with a decimal there, so I know that that's 2 significant digits. And I am looking for the acceleration first. So A is equal to VF minus VI over T. You know what, I just messed up right there. I'm not looking for the acceleration. I'm looking for the final speed after 1.5 seconds. My bad. So let's fix this, and let's go with the formula that would work. VF is equal to VI plus AT. VI is 0. A is 20. and T is 1.5. So 20 times 1.5 is 30 meters per second. And there's two significant digits there. And then they want to know how far does it travel in 1.8 seconds. So I'm going to say 1/2 AT squared plus VIT. VI is 0, so I can cancel those out. A is 20 meters per second squared. And T is 1.8 seconds squared. So I'm going to stop and get my calculator and figure that out. Okay, so when I did that on the calculator, I got 32.4 meters. And notice that every number I write down has a unit on it. Okay, the fifth one. Number 5 says a skydiver jumps from a helicopter hovering at a high altitude. If there were no air resistance, so we don't worry about taking away any of the speed, how fast would she be falling 12 seconds after jumping? So it doesn't look like they give you much information, but they really do, because if she just falls, she is going to be falling from rest. And we're looking for the distance. And we know that gravity is going to be acceleration of positive 10 meters per second squared. So I'm going to look for the distance that she falls in 12 seconds. Get rid of that because the initial speed is 0. A is 10 meters per second squared. And it's going to last for 12 seconds. So distance is 720 meters. But I have two significant digits. I'm going to write it as 7.2 times 10 to the 2 meters. And then I'm going to pause the recording and check my math. Be back in a second. Okay, that math was good. So I did number 5 correctly. I'm going to go on to 6. The ocean's level is rising at 1.5 millimeters per year. You've seen this before. We did this in class. It asks if they're at this rate, how many years will the ocean level be, in how many years will the ocean level be 3 meters higher than it is now, higher. So that's 3 meters. 3 meters is 3,000 millimeters. We're looking for the time. Well, time is distance over average speed. So 3,000 millimeters divided by 1.5 millimeters per year is going to be 2,000 years. So you have seen this one before. Okay, number 7. Number 7 says Mr. Klutz drops his physics book off his high-rise balcony. It hits the ground below 1.5 seconds later. With what speed does it hit the balcony, and how high is the balcony? Ignore air resistance. So we know that our time is 1.5 seconds. We know that he dropped it, so the initial speed is 0. We know that we're looking for the speed that it hits, BF, and we know that we're looking for how far it falls. We know the acceleration is a positive 10 meters per second squared because it's gravity. So VF equals VI plus AT. VI is 0. A is 10. T is 1.5. So VF is 15 meters per second. Distance is 1/2 AT squared plus VIT. Again, VI is 0, so we can ignore that. 1/2. A is 10. And T is 1.5. Don't forget to square it. So that's 2.25 times 10 is 22.5, and half of that is 11.25 meters. All right, number 8. Number 8 says a rocket traveling at 40 meters per second, so that's VI. accelerates at 2 meters per second squared. And I'm going to go back up here and fix this one so I have two significant digits. And we know that number 9, let me see, got VI, got A, looking for, there's my distance. And we're looking for the final speed. So VF squared equals VI squared plus 2AD. VF is what we want. VI was 40 plus 2A D. So when I multiply 200 times 2, I get 400. 2 more times is 800, so that's 800 meters there. 40 squared is 1600. And this should have been meter squared per second squared. Meter squared per second squared. So VF squared. So now I need to take the square root of 2400. So I'm going to pause for a minute. And when I take the square root of 2400, I get VF is 49 meters per second. Now I want to go back up here and look at number 7 because I didn't pay any attention to my sig digs in that final answer. And I should only have 2 sig digs, so my final answer here should be actually just 11. Okay, I'm going to post this on YouTube.